Alrighty, guys. We are continuing solving radical equations, okay? I'm working on worksheet 7-3A, okay? And your homework is from section 7.3, okay? So you're solving a couple radical equations. Remember, you must check, okay, these. So we're following the same idea as what we did here, okay? So we're going to isolate the radical, raise each side to the power equal to the index, and then solve the equation using techniques from previous chapters. So what you're going to see is some of the equations might get slightly more challenging today, and then we're going to check our solutions, okay? So we're going to isolate. That's the big thing here. Now, if you look here, there are two radicals in this equation, okay? So I need to isolate one of the radicals, all right? So if you take a look at this guy, what you can do is, since this whole quantity is underneath that radical, you can add that whole radical to the other side, okay? And then you will have the square root of 2x, right, equals the square root of x plus 1. And if you look, everything underneath, I should say everything on this side, the 2x is all underneath the radical. So there's no multiplication to that radical or addition or subtraction. And the same thing here, the x plus 1, that whole quantity is underneath the radical. So when I go to isolate these, I've actually already done that because there's no other operations other than the ones underneath the radicals. So now when I square both sides, right, I can just, the squaring and the square rooting, right, because there's an index of 2 here, so I squared it. They cancel one another and I get 2x. And then this squaring and square rooting are opposites, right? Inverse operations. So then I just get x plus 1. And then this is a very simple equation to solve, right? I'm going to just subtract x. And then I get x equals 1, all right? And then what I do is I check it. Now, important, always check an original equation, okay? So when we have an equation like this, you want to make sure you did every single step from the beginning correct. So you have to check in the original. So this should be the square root of 2x minus the square root of x plus 1 equals 0. So the square root of 2 times 1 minus the square root of 1 plus 1 equals 0. So it's the square root of 2 minus the square root of 2, which equals 0. So then that becomes 0. So we are good, okay? We can check that guy off. So now, if you want, you can practice these guys, okay? I'm not going to do number 3 because we've already done that before, but if you look, I'm going to kind of go in opposite order. If I look at number 5, that's very similar to what we did here. So I'm going to add the square root of x to both sides, okay, and isolate this radical and put the other radical on the other side. Okay, so add that. Then, since both radicals are isolated, I'm going to square both sides. So then squaring and square rooting cancel one another. And I just get that, right? So then if I subtract 3x from both sides, I get negative 2 equals negative 2x. Divide by negative 2, and I get x equals 1, okay? Now, if I do my check, okay, I've got the square root of 3 times 1 minus 2, all underneath that radical, minus the square root of 1 equals 0. So 3, right, minus 2, that's just the square root of 1 minus the square root of 1 equals 0. Anything subtracted from itself is 0, so 0 equals 0. So we're good. So that checked, right? Our first, so it just happens they both happen to be 1, okay? This guy I put 2 stars next to, it's a little tricky, okay? You can hopefully see that this radical is isolated, right? The x plus 3 is all underneath the radical. Here, we do have a coefficient, okay, to this radical. I would like to maybe bring it to the other side, but if I divide by 2, then this is going to be right, divided by 2, and that's going to be ugly. So you can square a radical with a coefficient. What you have to be careful of is you need to remember to square the coefficient as well, okay? So if you think about it, this is 2 square root of x times 2 square root of x, right? So 2 times 2 is 4. And then anytime you multiply, right, a radical times itself, those are opposite, right? Squaring and square rooting are opposite, so this just becomes x. So the radical will disappear, it's just you have to remember to square, right, the coefficient, because that's not under a radical, so that gets squared, all right? And then x plus 3, so then I subtract x, and then I'll have 2x plus 3. So then, if I, let's see, subtract x, I get 2x equals 3. Oh, sorry, 3x equals 3. What am I doing there? 3x equals 3. So then divide by 3. Oh, look at that. That's so weird. X equals 1. Don't think that everything is going to be x equals 1, okay? But that's our equation. I should say that's our solution that we're going to check. So now if I go to the original for my check, okay, I will have 2 times the square root of 1 equals 1 plus 3, right? So now 2 times 1 is 2, right? Then the square root of 4. When you're doing your check, you're only using what's called the principal square root or the positive square root. So if this had been a -2, that would not work. You always just take the regular square root like your calculator would give you. So if I go to the square root of 4, right? Oops. Would help if it's on. Square root of 4, right? That gives me a 2. Now, if you remember, when we were solving equations, the first half of this unit, we always did a plus or minus if it was an even index. But here, when we're just working with numbers and not solving, you're only using the principal square root. So this number that the square root is equal to in your check should never be negative, all right? But the square root of 4 is 2, so 2 equals 2, so we are good, okay? So x equals 1, all right? So oddly enough, all those turn out to be 1, all right? And they do check. Now, we've seen this word before, extraneous solutions, right? So that's a solution, right, that is going to be created that does not work in the original solution, okay? So because we're squaring something, okay, or possibly cubing something, depending on the index, this could have extra solutions, okay? So, solutions that don't work, don't check in the original equation, okay? So I just did a couple of abbreviations there, all right. So, if you take a look at this guy, this is a radical equation, right? I have x equals the square root of x plus 6. There's nothing being multiplied or added to that radical, so this has been isolated. So that's my first step always. So now I'm going to square both sides. Since my radical has been isolated, I get x squared equals, squaring and square rooting cancel, so I just get x plus 6, okay? So now I've changed the equation, all right, by squaring both sides. So that very often can create extraneous solutions because now I have a quadratic equation. Remember, when you have an x squared, right, in your equation, that's a quadratic. So if you remember, when you have a quadratic, and we will have this on the homework, you're going to get must be equal to 0, then factor. Okay, so we're going to get 2 solutions here generally, okay? So you always want to keep x squared positive. So I'm going to subtract x equals 6, and then subtract 6. And I'm going to put that in standard form, right? With the x squared first, then the x, and then the constant, okay? Then if you look at this, hopefully you remember that this is I am, or the trinomial method. Okay, so when I go to do this, right, I'm going to multiply to -6 and add to -1. So that has to be, I think, -3 and 2. So then I get x minus 3 and x plus 2 equals 0, right? Those two numbers go into my set of parentheses. And then x minus 3 equals 0, right? So x is 3. And then x plus 2 equals 0, so x is -2. But then, I know everybody's super excited about this, I know that. We have to do our check, okay? So we're gonna have to check not once, but twice. So check x equals 3 in the original. So 3 equals 3 plus 6. So 3 equals the square root of 9. The square root of 9 should be equal to the positive, right? Square root of that, so that's correct. So 3 equals 3, right? So this guy's good, so we're good with that. That guy checks. Then we do our check of x equals -2. And I have -2 plus 6. So -2 equals square root of 4. Now remember, whenever we do our check, it should be the square root of 4 equals the positive square root of 4, which this does not, it equals a negative. So this does not check. So then that is not our solution. So the only solution is x equals 3. This one is extraneous, okay? Or another way to say that is extra, okay? That's what I think of because it's kind of like hidden in there, right? That word extra. So it's an extra solution that doesn't work, all right? Now, last but not least, we did this before, okay? So I'm just gonna review this, but again, notice I'm saying extraneous solutions. So when I give you a quiz on this, and I believe that's gonna happen later on this week, because we have today checking extraneous, our next lesson will be a review, and then we'll have a quiz, right? A shorter quiz, definitely shorter, maybe 3 to 4 questions, all right, on this topic, all right? And then we'll move on to our next unit. But if I take a look at this guy, there's no radical that I see, but remember, a exponent of 3 over 2 is really a radical itself, so I'm going to isolate x to the 3/2 power. So I'm going to add 2. So then I have 3/2 power equals 27. And then if you remember, I want this to be x to the first power, so I'm going to raise to the reciprocal power. So then this is 2/3 and 2/3, okay? So then these cancel because they multiply to 1, okay? And then 2/3 power, what I'm thinking, okay, and you can also put this in your calculator, okay? But 27, this is power over index, right? X equals, the cube root of 27 is 3. 3 squared is 9, okay? You can also, in your calculator, okay, just do 27 raised to the 2/3 power, okay? And the calculator will give you the same answer, okay? I just thought of it in radical form and then did the cube root of 27 and then squared that, right? So we got 3 squared. But it's up to you. Now, check for extraneous. So they're giving us a hint here. This might not work. We'll see, okay? So what I'm going to do is do a check in our original. So 9 to the 3/2 power minus 2 equals 25. So remember, this is really power over index, right, of 9. Minus 2 equals 25. So the square root, okay, of 9 is 3. 3 cubed is 27. Okay, again, you can put that in your calculator if you want, all right? But you should get 27 there when you're doing your check, all right? So I should see a check on all your equations for homework tonight. And then we got 25 equals 25, so we are good. So this checks, okay? That was not extraneous, it works, all right? Let's take a look at these two. Okay, so I'm not going to do that guy, all right? We'll do just 7 and 8, all right? So this radical has been isolated, okay? So I'm going to square both sides. So then I get x squared equals x plus 2, right? Because squaring and square rooting cancel. I see my x squared, just like I had on my previous example, right? So now we're dealing again, kind of like this one, if you remember. So we've got a quadratic when we square both sides. So now I'm going to get this equal to 0. So I'm going to subtract x. And then subtract 2. And then when I look at this, this reminds me of IM. All right, so we've got an x squared, so we're going to get it equal to 0. Then this is IM, or trinomial, depending on how you think about it. So I've got to multiply to -2 and then add to -1. So I think that has to be a -2 and 1. So -2 and 1 means that I'm going to have x minus 2 and x plus 1 equals 0. So x equals 2, x equals -1, right? And then I do my, everybody's super famous, super popular checks. So x equals 2. So if I go to my original equation, 2 equals the square root of 2 plus 2. So that's what? 4. The positive square root of 4 is 2, so 2 equals 2, so we are good. So x equals 2 is not extraneous. We're good on that. X minus 1, x equals -1. Well, when I do my check there, it's -1 equals -1 plus 2. I'll tell you right now, I know this is not going to work because when I take the square root in a check, it should always equal the positive square root, and it doesn't here. So that means this does not check. This is extraneous. So we only have one solution, x equals 2, okay? Now, last but not least, if I look at this guy, I'm going to add 8, isolate, right? This fractional exponent, right, which is really a radical, so isolate that. So x to the 3/2 equals 8. Then I'm going to raise to the reciprocal power. So x equals 8, right, is really 8 power squared over index of 3. So the cube root of 8 is 2. 2 squared is 4. Okay, again, you could just put that in your calculator, 8 to the 2/3. I'm fine with that. So we got x equals 4. Now we got to do our check, right? And I will tell you, remind you to check on your quiz, all right? And you should be doing that on your homework. So then we have x to the 3/2 power minus 8 equals 0. So 4 to the 3/2 power minus 8 equals 0. So remember, 3 is the power. This is my index. So 4 cubed, and then the square root of that. So square root of 4 is 2. 2 cubed is 8. 8 minus 8 is in fact 0, so we have a check. So that is not extraneous, okay? So that is our lesson for today, all right? So the big thing is checking your solutions here and making sure you know how to solve something that ends up being a quadratic, all right? So try your homework, all right? And tomorrow we will do some review, and then we'll have our quiz at the end of the week, all right? Hope you guys are doing well, and I will speak to you soon.